All right. Hello, everybody. Welcome to OpenCV weekly webinar. And today we have with us Catherine Scott, who is the developer advocate at Open Robotics, the organization that maintains the Robot Operating System, or ROS. Welcome here, Catherine.
Hi, it's nice to be back.
Also with us is Phil Nelson, who is the content manager at opencv.org. He is responsible for putting these webinars together and a ton of other stuff related to OpenCV competitions and a lot of things going behind the scene at OpenCV. Hi, Phil.
Hey, good morning, everybody. Good morning, Satya. Good morning, Kat. Thanks for joining us again. This is Kat's second episode. We love having the repeat guests. We like to talk about how OpenCV is a community, and the people in the chat here and our repeat guests are, the proof in the pudding. Thanks for joining us out there. If this is your first time joining the OpenCV weekly webinar, or if you just need a little reminder, we do a couple things here every single week. One of those is a special giveaway to one lucky viewer in the Zoom chat. Satya, would you like to tell them what they'll win later on in the show if they answer our trivia question correctly?
So we will go again with OpenCV courses. You get a chance to win any of the courses. So people know beforehand what are the various courses. We have 3 courses: Computer Vision 1, which is an introductory course in computer vision; Computer Vision 2, which is for applications; and Deep Learning with PyTorch. And if you are already familiar with computer vision techniques, I would recommend Deep Learning with PyTorch. But if you are completely new, I would recommend Computer Vision 1, which is the introductory course. All of these courses are full of practical projects and tutorials, etc. So it's a very good learning experience, and they are very deep courses. You learn a lot. So you can pick any of the courses.
Excellent. Thanks for that. The other thing here is we use the Zoom Q&A functionality. At any time during the webinar, if you out there in the audience would like to ask a question of Satya or Kat or myself, please use the Zoom Q&A functionality to do that. There's a little button down at the bottom of the screen. Tap it, ask your question. We'll try to flow it into the conversation if it fits. If it doesn't, we also reserve time at the end of the episode to ask some of those hang-on questions.
Yeah, and the questions when we ask, the answers, we look at only Zoom because LinkedIn is out of sync. So if you want to win this little quiz trivia at our show, you have to answer, unfortunately, only on Zoom because LinkedIn is out of sync. So let's get started, Kat. Really great to have you again here. Take us through what's new at ROS. And also, how a little historical perspective on how ROS came to be, and also our relationship with OpenCV.
Cool. Let me share my screen here, make sure everything's all set.
Yeah.
We got the sound share. Yep. Okay, cool. So as Satya said, I'm Catherine Scott. I'm the developer advocate over at an organization called Open Robotics. If you don't know Open Robotics, you may have heard of Open Source Robotics Foundation, OSRF. So Open Robotics is sort of the continuation of OSRF. So I was on, I think 6 months ago, right? It was in June. So I figure last time I did the like full ROS history, what it is, how you use it, what's it do. So this time I'm like, let's do that real quick, and then I'll kind of talk about cool stuff going on, maybe debrief ROS World, a bunch of the computer vision talks that were there, and then talk about some cool, like some relevant, computer vision relevant projects and ROS packages that have come out in the past 6 months. So as I said, I was here in June of 2021. So if you want like a debrief on how ROS works, all the parts involved, how you use it, what's it good for, go see that webinar and then kind of come back to this one later on, because I'm just going to talk about the new and interesting stuff. The short of it is ROS is the biggest open source robotics library in the world. It's mainly C++ and Python, runs mainly on Linux. You can run on Windows and a few other places. You can run it on various flavors of Linux, but generally, if you're starting out, I would recommend you try Ubuntu and the specific version of Ubuntu that's tied to the ROS version you're using. And sort of one of the killer apps of ROS is it effectively has a package manager, kind of like Python. So, you're not building a robot from scratch. You're saying like, hey, did somebody write a driver for this LiDAR or this camera or, this motor controller? And you're able to pull all those packages in and glue them all together and get started pretty quick. So we essentially ROS, OpenCV, all got their start out of an organization called Willow Garage that I think was founded in 2006, 2007. You may know Willow Garage from the robot, the PR2. That was one of their big contributions, and the original Turtlebot. So essentially, Willow Garage existed, I think, from 2006 to probably about 2012. And it was this organization that was generally doing open source development for robotics and seeing how we could accelerate robotics using open source paradigms for software development. Out of Willow Garage came, again, these three libraries: OpenCV, Point Cloud Library, and ROS. So they're all sort of sister organizations and sister projects coming out of one sort of parent organization. So if you're new to ROS, you've never heard of it, I actually, in the past couple months, we released a big video. Now, this is more geared to sort of decision makers and, business types to sort of explain what ROS is. But I figured we could go watch it real quick because it's brand new, it's kind of cool, and it cuts to the chase of what ROS is. So I'm going to cue this up. I think I have it open already. Oh, I don't. So let's give it a shot. Sorry, I have the title bar over my top bar of my browser, so I gotta minimize it, open it back up to get a tab.
Computers.
Yay, computers.
Building robots is difficult. Motors, sensors, software, and batteries must all work together seamlessly to perform a task. But there's a way to simplify the process. The Robot Operating System, or ROS, is free and open source software that defines the components, interfaces, and tools for building advanced robots. Most robots are made up of actuators, things that move, sensors, things that read the world, and control systems, or the robot's brain. ROS helps developers quickly build these components and then easily connect them using ROS tools called topics and messages. These messages can be recorded using ROS bag files or logs for easy testing, training, and quality assurance. Messages can be easily sent to a variety of visualization and teleoperation tools. With ROS, you can work with a simulated robot instead of the real thing, which some call a digital twin. This also makes testing and training easier and more effective. ROS supports hardware interfaces for many common robot components like cameras, LiDAR, and motor controllers. ROS's modular architecture allows developers to build robots free from vendor lock-in or licensing fees. ROS can also work with just about any component. Anything that has a software interface is fair game. ROS 2 supports micro-ROS, a variant of ROS that runs natively on embedded microcontrollers running real-time operating systems. ROS's framework of common tools for robot development allows you to focus on addressing your problem, not on reinventing the wheel. This is why hundreds of companies, from small startups to Fortune 500 organizations, academic research labs, and government agencies, choose ROS as their robot development platform, and have downloaded over 500 million ROS packages in 2020 alone. However, ROS is more than just software. ROS is also a community of highly trained and pragmatic roboticists applying advanced robotics to every conceivable application while sharing their solutions with each other. When you choose ROS, you're tapping into a worldwide talent pool, community resources, and an ever-growing ensemble of services built on top of ROS. These services include logging and diagnostics, fleet management, deep learning data collection, testing, and quality assurance, and a whole lot more. The ROS community is now tackling every robotics market, including agriculture, factory logistics, autonomous vehicles, service robotics, food preparation, heavy industry, drones, planetary exploration, and so much more. This community is supported by the ROS Technical Steering Committee. These organizations use ROS to build better code faster, hire talented developers, and accelerate their time to market. To learn more about ROS and how it can be used to develop your robot, visit ros.org.
All right, so I bored you with the marketing video, but hopefully it explains things fairly clearly. I know it doesn't get down in the nitty-gritty of software, but you guys can go to the website, which is, again, ros.org. We just did a fairly big refresh, so you should be able to get started there, and it'll kind of start pointing you to all the different places that you need to go to sort of learn about ROS and learn about the different components of ROS. So let's talk about ROS and what's going on. So every year ROS releases a new version of ROS. We're constantly developing it. We have what's called in ROS 2, which is the active development version of ROS. We have a version called Rolling Ridley, which is kind of new to ROS. It's a rolling release. So it's just kind of every week we release new and updated code. And when we want to do a longer term release, we just sort of take that release, snapshot it, and release it to the community, and then do periodic updates. And so that release process actually has two components. There's the, taking the rolling release and taking a snapshot. And then ROS 2 is built on basically what we call a ROS middleware layer, an RMW. So that's the glue code that actually moves all of the data and information between the ROS nodes and the processes that are running in ROS. And so we take those two things, we figure out which RMW we're going to support, and we push it down with the rolling release, and we create the final release. So this one's going to be called Humble Hawksbill. We don't have a graphic for it yet, so these are some photos of hawksbill turtles I took on vacation. But that should be coming out on May 23rd. This is a very, very big ROS 2 release. So this is basically the second big ROS 2 release, and it'll be supported until 2027. And so we're hoping that it's a good time for people to move over from ROS 1 to ROS 2. If you're interested in this process, we just wrapped up the RMW selection. So if you're interested in how the glue code between basically ROS processes works and how it performs, because there's various vendors, you can actually check out this report here and get an idea of like how performant ROS is, or how performant the RMW layers are underneath of ROS, and generally people's feelings about them and how they're performing.
One other thing that may be worth noting is that for the same functionality, usually ROS can support multiple vendors, and you can choose which one works best for you. Isn't that true, Kat?
Yep. So there's multiple vendors. There's open source implementations, closed source implementations, ones that are specific to, sort of certain application domains. Like say I have a construction outside of my house. So certain vendors, may be better suited to say applications like I got to run this robot over 5G or something like that. And so it really allows a lot more flexibility than ROS 1. You're actually able to figure out how messages are going to be transported between different components of the robot, or between, say, the robot and something else. So not only does Open Robotics make ROS, we also make a simulator that's often used with ROS. So the simulator, if you don't know, it's kind of like a giant video game with built-in, but with like much, much higher precision physics. And the reason you need a simulator with a robot is that working on a real robot all the time kind of sucks. Say you're like, I don't know, example would be, hey, I'm making a vacuum robot. If you're making a vacuum robot and you have to test it, you're only testing it in, your bedroom, you're out there, or like your office or whatever, you're throwing dirt on the floor, you're running it. And really what you want to be able to do is like, hey, I want to try a whole bunch of different houses, all, set up all these different houses, and then make sure my robot actually completes his task in all of these different houses. And so that's why roboticists tend to use simulators. Just as the next release of ROS, Humble Hawksbill, is a huge release. Ignition Fortress was a huge release for Ignition. It came out on October 1st, and it's got a ton of new features. Got a bunch of new sensors built in, a bunch of just like general tools that make the development process easier, like wireframing and orthographic view and headless rendering and stuff like that. The big one that I think is relevant to the OpenCV community is one of our interns put in this super cool semantic segmentation camera. since it's a simulation, right? So it's a video game.
Right.
You drop like a, you're going to go set up your space. So let's take that house example. Let's say, you're building a house. You're going to drop a couch and a chair and a floor lamp, and you're going to drop those all in your environment. Well, you know what they are, so you can render them out as like a semantic segmentation or labeled semantic segmentation data. And then you can use that synthetic data to go and train your robot, or at least train it on the synthetic data to see how it might perform in the real world. There's always a little bit of a gap between doing something in the simulation or a video game and doing it out in the real world, but you can work out all the kinks in the process, sort of like validate that your ideas are roughly correct. And Ignition has a weekly webinar or monthly webinar kind of like this. And so sometimes we demo new features. So I went and grabbed a couple seconds of like this feature, the demo of this feature.
Okay, thanks, Luis. The segmentation sensor is about providing an easy way to generate data sets from Ignition simulation data so that people can use it to generate the data sets and train their deep learning models for computer vision applications. So one of the sensors is a segmentation sensor, which provides a segmentation maps, which an image
So just for some context here, up here there you can see the robot moving around, and then you can't see its view; it's occluded by the tree for whatever reason. But you can see the map that's coming out and being generated for that robot's view of the simulation.
Where objects with the same label will have the same color. For example, in this map, the chairs will have the same label, so that all of them will have the same color. That is a semantic segmentation, and same as for tables, same as for trees, and people can give a label to that object through the SDF model, and the sensor will publish the segmentation maps through Ignition Transport, so that we can access it via image display. And it provides two types of maps. One of them is the colored map, which is for visualization. The second one is the labeled map, which is shown right here.
All right, I'm gonna pause that. So what's cool about this, right, is generally every time I've been doing computer vision work, the hardest thing, the most expensive, the most tedious task is getting labeled semantic segmentation data. It's just, it's a ton of work. It's really expensive if you farm it out. It's not a wonderful process. But if you're a student, if you're, somebody who's starting a company and just wants to have like a proof of concept, you're just sort of messing around in your free time, free data, right? You set up your environment, you go get a bunch of models, you drop them in there, and you have you've actually created your own data set. You get to go through the process of learning like how you clean up that data set. So I think this is an amazing, amazing new feature that's worth checking out.
I'd like to point out that Ignition Fortress sounds like an awesome Scandinavian black metal band.
I think we all appreciate that.
Join us this coming Thursday for Ignition Fortress.
The segmentation camera is also very interesting because OpenCV AI Kit, Oak, they can be used as a segmentation camera. They are capable of running any neural network on the device as long as the memory requirements are satisfied and the speed is adequate. Semantic segmentation is one of the things that people can do on Oak as well. So when Oak is used with ROS, and as you know, I saw the video where Oak was also there. In the previous video, we could see Oak in the promo video. So Oak is compatible with ROS, and people who want to use Oak as a semantic segmentation camera can use it as well. So it ties in nicely with the whole idea.
It's a very interesting, like, I wish I had this when I was a student or just even a few years ago. This capability is pretty huge for computer vision. Let's see, other thing, and this is a project we don't talk about a ton, or we haven't talked about yet, So Open Robotics has 2 offices. One is here in California in Silicon Valley. The other one is in Singapore. And we do a lot of work at the Singapore office with, like, say, we have a lot of customers there, but we also work with, say, the big general hospital in Singapore. And the focus mainly at that office, one of the big things that we've been working on is this thing that we're calling Open RMF. And essentially what Open RMF is that you have all these fleets of robots, right? People are now having more, and RMF stands for Robotics Middleware Framework. I know it's not a very glamorous name, and it's probably not even all that descriptive. But what happens in these situations, say like a hospital or, I don't know, a fulfillment facility or something like that, is that you end up, we're quickly moving past the point where people have one robot doing work. Like even in my house now, we have the mopping robot and the vacuuming robot. Right. The problem is that the mopping robot and the vacuuming robot don't really talk to each other, right? They can both like push go, and they'll start like, you kind of want to sweep before you mop, but they don't know that. So they're, I might mop and then try to go sweep up afterwards. It just doesn't work. You need somebody to tell the robots when to do what they need to do, and then also deconflict resources between them. So, for example, say you're in a tall building, right? Like a 20-story building, and robots need to go from the first floor to the third floor to go do a task. You have a gopher robot. Those robots need to be able to interact with the infrastructure of the building itself. Like if a robot can't, interact with the infrastructure, with, like, say, the elevator, it can't push a button, it can't communicate with the elevator, you really can't get them off different floors. So what RMF does is it sort of does all of these inter-robot and robot to infrastructure communications for you. Another big thing that we've added recently is, robots don't have the same social constructs as humans, so they may not always, bear to the right when they're going down a cramped hallway. And you need a way to tell robots, hey, if you're going down this hallway, I need you to go to the right. And then I also, say you're in a situation like a hospital where there's high priority robots moving medication and there's low priority robots, cleaning the floors. The low priority robots need to yield to the higher priority robots. And sort of RMF is built to address all of these sort of meta robot problems. Other cool things that happened this year, we started a podcast at Open Robotics. It's called Since Think Act Podcast, and it comes from my coworker Audro. So about once every other week, Audro, there's all of these great ROS companies, and you hear about the robotics company maybe in the abstract, but you don't actually get to talk to roboticists in these companies about what they're doing, what it really looks like on the ground, and how they get stuff done. So we created the podcast to have people in, talk about how they're using ROS and how it impacts sort of their development process.
Yeah, whenever people hear about robotics, it's straight away to Boston Dynamics.
Well, there's a lot more companies in Boston Dynamics.
Exactly.
We're always looking for guests, and you can have a listen at sincethinkact.com. Other big thing that's happened in the past year. Did I get the video? Okay, it's there. So we're releasing a new robot, hopefully sometime in the spring. It's the Turtlebot 4. It's going to be the first all ROS 2 robot. Hopefully it'll ship, maybe not exactly coincide with the ROS 2 Humble release, but very, very quickly it'll support ROS 2 Humble. And we're building in a partnership with ClearPath Robotic. It's basically going to run ROS from the ground up, including the iRobot mobile base. That's this component down here. We're thinking it's going to be roughly Q2 of this year, but we're still, finalizing the date and finalizing the bill of materials that are going to be on there and the price. I'll show you guys a couple of things. We don't have to watch this. So this is what it's going to look like. And generally Turtlebots are geared towards, I have a single floor, with a hard floor, and I want the robot to move around, be able to map, be able to do plan, to do recognition, maybe some more advanced tasks about moving material from one place to another.
Has anybody built a Dalek shell for it yet?
I'm pretty sure they have. We kind of, when we were designing it, actually, one of the big asks was, can we get the shell such that there's mount points that you can cover it? It's one thing we have seen fairly frequently.
What's the maximum weight on that thing? Because I definitely want to ride it.
I think you're too heavy. I don't know off the top.
You don't know me.
Oh. Let's see here. So the other thing, and this isn't the greatest image, but the other thing that we're doing with this robot is that we're really pushing towards simulation first, which is to say everything that is going to, function on the robot is also going to be available in simulation. All of the educational materials will hopefully toggle between simulation and real. So what this gives you is not only like I can sit at my desk, work on my robot, go in the other room where the robot is and actually deploy code, but the hope here is that, robots are expensive. They're out of reach for a lot of people. And that there's only so much we can do. We can build a cheaper robot, but it won't be as functional as it needs to be to do the job. But what we can do is provide everyone with free simulation. So if you want to be in a position to learn ROS, to get familiar with all of the functionality and topics that kind of are related to robotics, all you need is a computer. You don't need the robot. You can sit down in simulation and it's going to behave mostly the same as the real robot. So I'm really excited about this. I think it's going to be great to be able to go into a classroom, have everyone have a simulation, and then they can sort of split one or two robots in their free time to go and see if their code actually works.
So this will also be simultaneously released with the TurtleBot?
Should be, yeah. We're still ironing out some of those details now, but it should be about the same time, if not sooner.
That's awesome.
So changing gears, ROS World is our big conference. Satya asked me to kind of, hey, what happened at ROS World? Is there anything cool that happened? And the answer is, of course, yes. ROS World is our yearly conference. So ROS World is the online version that we did because we couldn't do the real version, which is called ROSCON. But this year we had a full ROSCON lineup. A couple thousand people, or well over 1,000 people were there. And all of the videos are now free on roscon.ros.org. So take a look. There's a ton of great content related to everything from introductory level sort of tutorials on robotics all the way up to research grade or research projects. And so ROS World usually spans the gamut of all of those things. So there's a ton of content for whatever level you're at. So I went through and I went and picked out a handful of videos that I thought were extremely relevant to the OpenCV community. First one, and I think the most important one, is we had a keynote that was essentially from a couple of NASA scientists talking about the Viper project and the role of ROS in space research, which is incredible to see. We don't hear a lot of times when people use ROS, but when we do, and it's something amazing, we get really excited about it. So this is Kimberly Habuchin, who works at, I believe, she doesn't work at NASA Ames. I don't want to skewer her by, but I have to check. But one of the keynotes is basically talking about the role that ROS is starting to play in space research. You can actually, if you watch one talk, I would recommend you watch this ROS in Space one, and she kind of outlines some of the projects that are using ROS. I summarized some of them here, and this first one, I actually only really learned about a week ago that NASA Ames is using Gazebo and ROS to simulate potential. This is a Europa lander. This is not a moon lander. And this entire ocean waters, I don't know the acronym precisely. It's Autonomy Testbed for Exploration, Research, and Simulation Ocean Waters. Is a completely open source set of tools that have come out of NASA, and they use ROS and Ignition to simulate a Europa lander, which is pretty amazing. You can find all the source code. I put it right down there. So if you want to look at it, how an actual NASA project is built, it's there. The other one that's huge, and this one is actually in the ISS right now, or was, I'm not sure if it still is, Astrobees. These are like little tiny cube robots with fans and I think reaction wheels inside of them. Bunch of cameras, and they actually move around inside of the ISS and like help the astronauts do tasks like monitoring tasks and moving stuff around. And again, this is another, they use ROS to run the software on these robots, and all of the source code is open source. So if you're interested in how that functions, go check out this link right here. Interesting fact on these, I believe, I haven't looked at, like, poked at the source code that much, but I believe it's all, you know, the compute guts of this thing are essentially cell phones. And so it's all ROS in Java, which is kind of interesting. And then the other one that we're super excited about is there was maybe about a month ago, there was a big announcement. It's an RFI coming out of NASA, so request for information. NASA's like, we want to work with Blue Origin and industry partners to develop basically what they're calling Space ROS, which is open source or ROS that's space hardened for space applications. So this is super exciting.
Maybe we should talk to NASA about space OpenCV as well.
I am absolutely sure OpenCV is used in space in some capacity.
Of course, I mean, I know for sure that it is used, not in its native form. They basically take pieces of OpenCV, and because OpenCV is very large in that sense, but they take pieces of OpenCV and integrate it into several such applications.
Oh, I'm sure. And maybe on the ground too. Who knows? Maybe the maybe Hubble images were processed using OpenCV. Okay, so let's cut to a couple talks. So big one here. I thought this one was really cool. It's basically multi-sensor. It's a multi-sensor alignment package. And it's by this gentleman named Charles Ellison. This one's worth checking out if you're interested in LiDAR applications. So what happens is, right, you have to, when you have a self-driving vehicle or a robot, you may have multiple, if you like see them driving around San Francisco, right? They have like 5 LiDARs and 5 cameras sitting all over the vehicle. And to make it all work, you need to know exactly where they're positioned on the vehicle, and you need to align their readings such that they overlap, right? You need the sensors to overlap so you don't have any loss of, you can see all the way around you. And so this is a pain, right? It could be a guess and check sort of situation. So what this gentleman's done is he's made a ROS package.
Ideally, this would be zeros, just all 0 unit vector.
Goes and takes these individual readings and can actually bring them into alignment. I think he's using ICP to do this.
The alignment process running on a live robot. It's a recording, but this was from our live robot. So we've started up. We can see in blue is the reference sensor, in red is the misaligned. This will publish the green, and so that we can see that we actually like the alignments that it's finding, and it's publishing to the screen those alignments. And now we go and run a service call, which then takes those alignments and pushes it to the alignment publisher node.
You can see that everything
and
just
so now we
lined
have
up there, which I thought this was really just very
which
practical,
then takes those alignments and pushes it
bit of code, right? Like we see all these fancy papers all the time, but something like this, if you're actually out in the field, will save your life.
Extrinsic calibration is, I mean, there are whole companies that these are the problem they solve. Yeah, definitely.
Tanagram for sure, yeah.
Yeah.
Let's see. I think I saw him in the chat. This is not his work at Open Robotics, but this was my intern last summer. This is Patrick. So Patrick's, and I don't want to butcher it, so Patrick's here. I will butcher this, but this ROSCON talk essentially it's called Towards Assured Autonomy with ROS. And so what Patrick does is essentially, and I'm really roughly summarizing here, you have a neural net, and then you have that is going to tell you how to drive a vehicle. And then you have a model that says, is the thing that this neural net is going to tell me to do, is it, sane? Is it logical? Am I going to crash if I do this? And it's basically taking these two parts, the sort of model that constrains behavior so you don't crash into something, and the neural net model that is generally good at driving, and puts them together in a way that hopefully guarantees some safety in the system.
then you allow the inexperienced student to drive. So the idea here is to switch between a machine learning-based controller and a fallback strategy when we identify that an unsafe situation is imminent. And the way this is done in this architecture is that during each control period, we take the action issued by your controller, and you derive a set where describing where the system would be if this control action were to be used, through a technique called reachability analysis again. That comes with the benefit of provable guarantees of safety and a capacity to deal with uncertainty. And this reachable set is then used to check for collisions within your environment. If none are detected, then you can continue to use this component. And if not, then you can switch to the one that may not be optimized for performance, but can guarantee you safety.
And so I think this is really interesting, important work, right? Because we have all these autonomous vehicles now, and people, one of the most terrifying things I've heard is, hey, I'm going to go put this neural net on a vehicle that says, does driving, does full self-driving. And I may not have any, guarantees on the fact that it won't go and hit a pylon, or it'll like randomly veer off of course. And so you do want some constraints on the vehicle before it does something that's dangerous. So I think this is really, really important and really, really interesting work of marrying both the safety and sort of the flexibility of deep learning. Let's see, another talk. Nvidia was visiting for ROS World, and they had a great talk on using IsaacSim for synthetic data generation. Very similar to the stuff we talked about earlier. So IsaacSim is another simulation platform, kind of like Ignition, and they went and did a really quick demo of essentially what I showed you earlier, right? Which is create this complex environment. There's lots of different components, and then being able to use those simulated components to build various kinds of semantic labeling for deep learning. I think I have a demo here. Oh, no, I didn't actually pull up the demo.
Are some of these packages built on top of tools like Unity 3D, or they are completely separate?
Well, the situation is right now, it's sort of like the XKCD. There's 18 competing standards. So there's 18 different simulators, each with their own, there's probably 3 or 4 big open source ones. There's 2 or 3, more proprietary ones like Unity and like IsaacSim. And they all have their particular domain in which they're better, right? So yeah. I think and I'll get to this in a second, if the vehicle's moving around, or like if you're doing vehicle stuff, I think a lot of people use LV VSL, or there's another one, Carla is, that are used just solely for vehicle stuff. Whereas say Unity, and I'm sort of talking off the cuff here, like say Unity might be better at doing very, very high fidelity rendering versus Ignition that has just sort of native ROS integration. And they each have their own little subspecialty, but there's a ton of them right now. There's a proliferation of simulators. And it's kind of an interesting time for simulation for sure.
So they are separate. They are not built on top of things like Unity, right?
Yeah, Unity itself is kind of, I think more what's happening in that case, right, is that people are adding on modules that sort of bring capabilities that would enable robotics versus building on top of.
Right.
Okay, so this ROSCON talk, when I got to see this maybe 8 weeks before ROSCON, it was jaw-droppingly good and amazing. And it turns out I actually met his co-founder for this company at ROSCON in 2016 or 2015, and they had just started the company and were in a basement in Boston working on this thing quietly for 4 or 5 years, and then to see the result of it,
wow, it
was quite amazing. So this is a startup called it's a product called Porvus. And this should give you a good demo of what they do. I guess it is Porvus Robotics. So this is their drone that's specifically tailored towards warehouse logistics. So you can see multiple cameras, the thing's taking off autonomously, mapping the entire warehouse, returning to dock and charging, and doing inventory. And this is incredibly difficult to do.
Right.
And this is all built with raw And so you can see a quick rendering of sort of the survey environment. Anyway, amazing talk. He sort of outlines that whole multi-year process of getting this thing working, all the components in there.
Wow.
Very, very interesting talk. Very, very interesting company and very wonderful people. So that was probably one of my favorites at ROSCON. Last one. So we do, if you're not in for doing a big ROSCON talk, we do lightning talks too. And I thought this lightning talk was so good. It is like 90 seconds, and it's about a topic called visual teach and repeat out of a research lab at the University of Toronto. And this is actually relevant to some of the space stuff and NASA stuff. A big topic in robotics research is navigation and mapping in GPS denied areas, right? So a lot of these military applications, they're like GPS won't exist in that case. You can't use it. You have to be able to navigate without it. And then if you're, obviously exploring another planet or a moon, we don't have a GPS system set up on that planet. So you need a way to navigate without it. And this is a technique of essentially, you take a robot out, you walk it around, and it builds a map on the fly and is able to re-navigate it. And I thought it was just a really well done short talk.
In this short presentation, I'd like to introduce one of our recent projects, VTR3, that brings visual teach and repeat into ROS2. So what is visual teach and repeat? In short, visual teach and repeat, or VTNR, is an end-to-end navigation framework for long-range and long-term path following in unstructured environments using only vision. With VTNR, the robot requires only a single demonstration of the path to follow, and is then able to repeat this path indefinitely across significant environment changes. And it's all achieved using just one camera, one laptop, and there's no GPS involved.
Wow.
So far, we have been working on VTNR for quite a few years and have successfully deployed VTNR on many ground and aerial vehicles.
And I believe
However, this won't be the whole story.
They have a ROS package, so this is just something you can try to use. I'm sure it requires a little bit of tuning and such, but I mean, the fact that this is a thing that's just being built that is open and free to use is amazing.
That's great.
Yeah, that's all the quick summary. I could go on for a long time. You can check out all the talks. Those were the highlights, I think, from a computer vision perspective. But we're planning ROSCON 2022. I think we're going to try to do it in person. It's supposed to be the second to last week of October, and this year, so we alternate when we have ROSCONs. We alternate between Europe, America, and Asia. So, in theory, this year is going to be in Kyoto. Hopefully, it's happening. We're starting to plan it. So if you're interested in submitting a talk or attending, just kind of watch roscon.ros.org.
Always wanted to visit Japan, hint, hint.
I demand you guys come visit.
Cat demanded it. I guess we're going to have to.
So new and noteworthy. So I figure I just run down. So I write a weekly summary of ROS news and, administer the forums and so forth. So I generally get to see all the cool stuff that's coming out. I figured I'd point out a few other things that I think are kind of relevant to OpenCV here. What do you got? 15 minutes left? Okay.
Yeah.
Should be cool. I'll speed it up a little bit. So first big one is we are Open Robotics has been working with Nvidia. So we were approached by Nvidia to work on improving sort of the speed at which ROS does certain tasks, or see if they could be accelerated with Nvidia hardware. And we're, for what it's worth, we're doing this in a very abstract process. It's not necessarily always Nvidia. But the hope here is that, there should be hooks in the future, fairly soon here, where certain ROS calls can be accelerated with Nvidia hardware. So things like, in particular, computer vision tasks, some of the pathfinding tasks could all be accelerated on that hardware and run a lot faster. So this is a big project for us. You can find more information at Nvidia. And I don't, ROS is sort of vendor neutral in terms of implementation. So there are other hardware vendors doing this. Xilinx has been doing a ton of work with our hardware acceleration working group in this domain as well. So it's not just, one vendor. I think we've been roughly approached by most of the big chip vendors on how do we end up making ROS faster for this set of hardware, which I think is a big big thing for us. It's
Yeah.
and I'm sure you guys have seen this too now, where
Yeah.
it's like, oh, everyone's using this. Let's actually make it fast for the end user, which I think is amazing.
Right. And every hardware, I mean, it's not for specific vendors, but you still need to do things for specific vendors because they may have specialized hardware. And if the hardware is popular, like NVIDIA's, GPUs, etc., then you have to mimic the same functions in many different hardware, right? So if you look at even OpenCV source code, you will see that the same function is implemented in many different ways for specific hardware. And the challenge there is to make sure that all the results are the same when these optimizations are done, right? So it's a non-trivial amount of work to do this, but if it works seamlessly for the user, it is such a big boost. So they don't have to do anything. Transparently, it figures out, whether it needs to use the GPU. If, let's say, if CUDA is installed and they are using NVIDIA GPU, the same function can run on the GPU and give a boost without even the user doing anything extra. So that's a great initiative. That's a great initiative.
Yeah, it's kind of pretty exciting to see things speed up so much. Big project just wrapped up, and so disclaimer, I don't speak on behalf of DARPA. I'm not a representative of DARPA, but the DARPA Sub-T Challenge just wrapped up. If you're not familiar with this, this has like been a multi-year huge robotics competition. Essentially, DARPA takes these robots underground into these very dark, dingy, scary environments like caves, mines, abandoned subways, that kind of thing, and has them complete tasks like finding different objects. And it's a big, huge robotics competition. It actually had both a simulation component, doing that exact same process in a very high fidelity simulation world, and then in the real world as well. And so this just wrapped up. Tons of robots, tons of different approaches, lots of really cool code. It's worth checking out both the DARPA broadcast, and I think we're at the point now where a lot of the competitors are kind of doing their postmortems on the event, and it's just a really, really interesting way to see how like these robots get built, how people program them, how different strategies panned out. If you're interested
just
in
how
this,
different physically they are is really interesting to me. There's a lot of different ideas there, and it's very cool to see.
oh, I didn't put there's one. I didn't put it in here. It is the crowd favorite. When I went to go, right before the pandemic started, I went to one of the competitions, and one of the teams actually used the blimp, like one of these, like,
A dirigible?
A dirigible, yes. It was an autonomous dirigible, which I thought was kind of cool. It's a
That's
crowd favorite.
awesome. Yeah.
If you want to give this code a try, we actually have a full set of tutorials where you can use that exact same simulation environment and replica robots to actually traverse an area and see how well you can perform the task. And that's down here.
That's great.
Definitely a great learning opportunity if you want to learn about ROS. Other stuff going on. As of, I think this was last Thursday? No, it's last Friday. CES, big consumer electronics show in Vegas. One of the cool things that was going on there is there's this thing going on called the Indi Autonomous Challenge. It's a bunch of college students essentially racing. I think they're one step down from like the professional Indy cars, but they're all instrumented with, all your Velodynes, all your cameras, all your radars, and a bunch of student teams from various universities. I think like, TUM and University of Munich and Virginia Tech and a few other teams made it to this final round, and they all get to deploy their own code to one of these vehicles and try to have them race around Las Vegas Motor Speedway. I think most of the vehicles run ROS2 and AutoWare, and they're going in excess of like 100. I think the top speed I saw there was like 175 miles per hour. Right now, they're not racing against each other. They're just trying to get them go around the track and then like do basic maneuvers like passing, but still really, really interesting to watch. And you can learn all about that at Indi Autonomous Challenge. Somewhat related, there's a new program going on. It's called F1/10th. So F1/10th is autonomous racing at RC car scale. So this is sort of like almost the feeder league to that bigger competition. Open Robotics isn't affiliated with this. It's just one of these things that's going on that I think is relevant to the audience. It's essentially just student-run teams building cars, racing them, learning about ROS, learning about how to do robotics and computer vision. It's really, really interesting work. Find a little bit more there. Other cool new things. As of last week, we now have a complete guide for using the Nav2 stack. So Nav2 is essentially the SLAM and mapping and navigation package for ROS2. It's all open source and it's all extremely well documented at this point. Turtlebot's going to run it. Most, AMRs or, small mobile robots run some variant of Nav2 at this point. So if that's something you're interested in from a computer vision perspective, doing doing SLAM, moving a robot around, understanding how mapping works, this is an incredible resource and worth checking out. I'm gonna burn through some of these real quick because they're just cool packages that have shown up in the last week. Orb3. So you guys seen the Orb3 stuff yet? Pretty amazing. Just launched. I hope fairly soon it'll get into a ROS package, maybe even Nav2. Just came out. Big announcement on ROS Discourse.
Yeah, huge performance improvement there from the video I saw. Yeah.
Mm-hmm. I just found out about this one last week. This is over at UC Berkeley. It's called Fog ROS. I'm not particularly keen on the name, but it's essentially what it is a ROS package that basically generally people that do deep learning, and this is a generalization, aren't always great at doing cloud infrastructure work. So this is a ROS package that lets you take, say, a ROS node, which could be your deep learning model, your planning code, whatever, and basically automatically will spin up a connection to Amazon, spin up your instance, deploy your code, run something, and then shoot it back to your robot. I thought this was really cool. If all that stuff's too intimidating, but you still want to say run a remote model on a server and then get it back to your robot, really cool package. Oops, I think I'm missing one. Did I miss one? So that is about all I got. I must have deleted. No, there's one more. There's a big, that's strange. Check my slides this morning. There's one more. There's a big, and there was just a recent announcement about it, a giant effort by a set of European research scientists to, it's called Open Deep Robotics, and it is essentially a set of deep learning tools plus ROS deployment code for doing general deep learning tasks in ROS. And it's a collaboration between I think 6 to 8 universities in Europe. And then finally, I'm going to wrap up here. Where to get more information? Generally, you can go to ros.org. Our big user forum is over at discourse.ros.org. If you're trying to get started with ROS, docs.ros.org is your best friends. And then finally, answers.ros.org. If you have any questions, we have our own Q&A forum. It's kind of like Stack Overflow, but you'll get a hold of the core devs really quickly, and that's a great way to get your questions answered. So that's what I got. Questions, comments, concerns?
Awesome. Yeah, thanks. Yeah, thanks, Kat. Yeah, so we'll do our trivia question real quick, and then we'll take some questions from the audience. I don't know if you have to run immediately, or if you can stick around a little bit after our 10 o'clock end time and answer a couple. Okay, great. So first, we're going to ask a trivia question. Those of you joining us on Zoom will be able to answer this question in the chat window. The first person to answer the question correctly will win. Will you tell them what they'll win, Satya?
They will win one of the OpenCV courses of their choice, and the choices are Computer Vision 1, an introductory course in Computer Vision 2, which is about applications in computer vision, and Deep Learning with PyTorch, which is an introductory course in deep learning.
Great. Yep, and you'll have your pick of those awesome courses. We've been seeing a bunch of great responses for those. A lot of people even got them over the holidays here, investing in their futures and careers. It's always a smart move. So get ready to answer our trivia question for this week. Again, in the Zoom chat, and the first person wins one of those courses. Earlier, Cat showed their new TurtleBot in a simulation environment that's been used a lot for over a decade now. What is the name of that simulation environment? I see Varunjith. The answer is Gazebo. Well played. It's a new one. We didn't even have to discount one of our common question answers this time. Partha didn't get it. So please send me one email to phil@opencv.org, and we will make sure that you get the course of your choice.
All right, now we have 2 questions.
Yeah, so I've got a bunch of them here. I'm gonna pick one. Kay would like to know how is Kat, could you talk a little more about how the environments are being created for these simulation first robots?
Yeah, I mean, it's the same way that you build a video game, right? I mean, there's new tools, right, for doing this stuff, or they're not new anymore, really. So, like, take for example the DARPA Sub-T stuff. They actually went out and like did photogrammetry scans of like some of these caves and did a full 3D reconstruction, so that raw data comes into us. This is actually one of the services Open Robotics offers, is that, you know, we got all these models, we got sort of a list of what the environment should look like, and so we went and built the models, built the environment, and dropped everything in there. So it's still a very bespoke process. It's not like something that just is automatic. You have to go and, you know, either if you want to do like something that's very realistic, you have to go scan the object or recreate it. You know, you can do other things where it's just like there's totally, you know, 3D stores where you can grab like, I need a table and I need some books, and I can drop them all in there. So it's some combination of those approaches is making it happen.
Great, thanks for that. David would like to know, so you mentioned that ROS World or ROSCON this year is meant to be in person. Will there be a virtual, you know, version of the event as well for folks who can't make it to Kyoto?
It really is going to depend on what the situation is. I mean, if it's with regular ROSCON, what we normally do is that we have a live stream, so that will always be available if we're having a live event. You know, if something were to come up, if we couldn't get to Japan or travel were restricted, I'm sure we'd pivot like we've done in the past. But generally, if we're having an in-person event, the most we're going to offer is a live stream, so you can watch everything. Videos are always going to be posted for free, you know, a couple weeks afterwards as well.
Excellent. Got a couple more here. Several people have asked about the embedded microcontrollers and the even some of the dedicated, you know, robot-focused platforms like Nvidia Jetson, of course, is one of those. Raspberry Pi. A couple of folks have also asked about some of the smaller and like lower power devices like Arduino or those sorts of devices. Is there any way that ROS works on even those lower calorie devices, like sub Raspberry Pi compute power stuff?
So so there's some caveats here. With ROS2, which is generally what I'd recommend that you learn. If you're new to ROS2, there is something called micro ROS, which is a scaled down subset of ROS that runs on a microcontroller. It's possible. You're not going to get the full functionality, right? Like if you're using an Arduino, you're not building, for lack of a better word, a big kid robot, right? You're building a simple robot that bounces around. Like generally a robot, like say an autonomous vehicle or an AMR, you know, one of these robots that's moving around in a logistics fulfillment place, it's going to have a fairly beefy thing, more like a Jetson or, you know, I've seen Nvidia NUCs. I have people always ask, what's the best? There is no best. The best is like, that's the job of an engineer, is to figure out what the best hardware is for your robot application. I can't really tell people what the best is. You know, I've seen micro ROS. I think it runs on ESP32 at this point too, like that subset of command or subset of ROS. Really what most people are using that for though is to interface with actuators, maybe some sensors. you're still going to do your high level planning and control on a more beefy machine.
Yeah, that makes sense.
I have a question on behalf of the audience. Suppose I'm a complete beginner and I want to learn ROS and I want to get an actual robot to go with it. So should they actually wait for Turtlebot that's coming out later this summer? Where do they start, and what hardware should they choose in case they just don't want to work with simulation? They will work with simulation, but I also want to get my hands on hardware.
I definitely think that Turtlebot's, I mean, there's still a Turtlebot 3 if you're in an incredibly hurry to learn ROS. Turtlebot is the one that we generally recommend. And this might be a bit of a spicy take, but one common thing that I see, because I run the forums, one common problem that I see is that, especially if people are trying to learn, they bite off more than they can chew. And that's why simulation's good, right? Because
right.
When you have a physical robot, especially if you built it yourself, you are debugging the software on the robot and the hardware you built simultaneously, and you're don't know what you're doing yet, right? So it's very difficult. Whereas a simulator, you're kind of assured that the hardware is always going to work, and so it just becomes a software problem, and it just eliminates an entire class of error, and so it becomes easier to learn, I think, in that respect. I also see people quite routinely get frustrated just because things are so intimidating. There's the layer of hardware, right? So often as a roboticist, people are asking about Arduinos, something similar, some sort of motor controller is very likely inside of a robot. But when I, as a roboticist, am dealing with that robot, there's an electrical engineer and mechanical engineer that has probably put that thing together, and there's an abstraction layer, and I kind of just assume it works. Right. And so when you're in this, I'm going to build all the parts, well, you're in no man's land where you don't get any abstractions. You don't get to push away some of the complexity to someone else. And so I really recommend that people try to for lack of a better, partition what they're learning. And so there's a lot of really simple ROS demos. Go learn how to do ROS and go learn, the basics of microcontrollers and how to solder and do all that, and then start putting stuff together. Don't bite the whole thing off at once.
That's very good advice. That's excellent advice. I was actually hoping that you would say something in those lines, because I just wanted to reflect what the audience might be thinking, right? And even my son, who is 12-year-old, when we talk about robotics, the first thing he says that, "Oh, get me a robot." And I said, "No, you can do a lot without actually having your robot, a robot in your hand, right?" So that's really good advice. Do we have more questions, Phil?
Yeah, we've got time for one more here. Dale would like to know, are you aware of ROS being used in the Nvidia Omniverse environment?
So I'm not super familiar with Omniverse. It's a thing that I know about. I don't know a ton about it, perhaps. I mean, it's not something that really crosses our paths that often.
Makes sense, and it's relatively new as well. And Nvidia, they keep stuff kind of close to their vest before they push it out. So it's sometimes hard for packages to even add support, quickly, because Nvidia is doing it themselves. Yeah, I think we got one more here. We saw a really cool example of that drone video. Are there any other cool drone projects with ROS that are currently ongoing that you'd like to shine a light on as our last question here?
Well, we do have sort of a, for I guess maybe we'll call it a sister library, or if you're familiar with PX4, the PX4 people sort of own that space. And then there's MavROS, right, which is this linkage between PX4 and ROS. We're not going to replace what they do, which is incredible, on hardware control for these drones. And, I don't think they want to do what we often do, which is higher level planning and sort of interfaces. So I think that interface is really, really cool. So as starting out, I would check out the sort of PX4 communities. As project-wise, I don't know any cool drones that I've like heard of. The Porvus people really just floored me with that thing.
Yeah, we'll definitely have the direct links to those videos in the show notes when I get these up on YouTube. So, yeah, Satya, you want to take us home?
All right. Thank you, everybody, for joining. Thank you so much, Kat, for giving an update. And those videos that you shared, summarizing the talks for us, which would be relevant for the OpenCV community, those are really very useful. I'm going to check them out myself. And thanks for being here and giving us an update. Phil, thank you, as always, for putting the show together. And thanks to the entire audience for being here every week. See you next week.
Yeah, thank you, Satya. Everybody else, we'll see you next Thursday with Joseph Nelson about 2022 computer vision and AI predictions. Ooh.
Thanks so much for watching this episode of the webinar. Please hit that like button, subscribe, and don't forget to tap the little bell icon to be notified when new episodes drop. This week's episode was brought to you by OpenCV Courses. Learn computer vision from the experts at opencv.org/courses. If you'd like to be in the audience next week, subscribe to the OpenCV newsletter.